Alright, so in this video, I'm going to show off, this is kind of a miscellaneous video, show off all of the other parts to the project. We started buying components at the date of this recording about exactly 2 years ago. About two years ago exactly, the date of this recording, we started building. And over the time of us working on this project, a number of parts were accumulated, different things were tried out, hardware was tested, some of it didn't work. So this is just a video about, first off, all of the other parts included with the project, um, and about the different tools that are not included with the project that you'll need when you work on the device. Alright, so let's get started. So first off, first and foremost, included with the project there is a Lenovo ThinkPad 110, or I think so, running Windows 10. This is needed to connect to the DJI NASA V2 in order to configure it. You can also see there's the charger for it right there, and there's the laptop. Moving on down, we have extra components and other parts of the project. The idea of the spotter drone changed quite a bit over time, and because of that, we have hardware that can be used for flight and hardware that is just backups. So starting off with backups, right here we have a full set of multi-star motors, complete with their hardware and everything. These are for replacing the motors on board the device when they break. I'll get back to broken motors here in just a moment. We also have a set of 3 of the Afro 30 amp speed controllers. These are opto speed controllers right here. There's a full set of them still in the bag, never been used for in case that ever breaks. Next up, there's an extra FrSky X8R receiver for the remote. I'll get back to why this was purchased and why it might be needed again in the future here in just a moment. Alright, next up are other cameras and devices like that. First off here, this is a Raspberry Pi Model B, one of the earlier models, as you can see by the full SD card slot. If you look here, you'll see that it actually has an extra lead coming out the bottom. This has actually been soldered to the composite output of the Raspberry Pi. So this can actually be connected to a transmitter, just like this one here, in order to send the video signal out of it over the air. And then there's an SD card included with that as well, which contains the Raspbian OS for that particular board. Moving on down, we have another Raspberry Pi. This one's a Model 3 Raspberry Pi. See there, it's got the 4 USB ports and the micro SD card slot. This one also has a connector for AV out going to the transmitter, and it works. If you notice inside the case here, there's a camera. This camera is a no IR filter camera. That doesn't really change much about the camera. It's really just a basic camera. Honestly, the one already connected to it is just as good, if not better. This one's not wide angle. Originally, the idea was to have a infrared camera. This is not an infrared camera. It is a no IR filter camera, which means that it can see, the colors will seem a little off. It can be used at night a little bit better with the aid of infrared LEDs. I believe some of which are actually here. Um, but all in all, this can be used for other purposes as well. For instance, a speaker can be connected to it and then controlled remotely with the use of the controller. It may take a little bit of electronics and a little bit of Linux or a bit of Linux shell know-how, but you can use the Raspberry Pi here or even the other one to perform that action. Speaking of cameras, here is a Mobius action cam. It's got a heatsink here. I believe there's also a lead that takes this output here and converts it over into a couple different leads that the transmitter can receive. So this can actually be used in flight It does have a bit of a problem overheating sometimes, so maybe it's not the best option. But if you did want to add another camera to the drone, this would be the one I would recommend. This is also not a bad camera for filming as well. The quality is pretty similar to that of like a GoPro. It's got a wide angle lens there. There's also a sled for it and a tripod mount bracket as well. All right, next up, going along with the Raspberry Pis, there is a battery here. This is one battery that you might use to like charge your phone. And this was attached to the drone for a very long time. We intended to really use the Raspberry Pi as a secondary camera. Um, Ultimately, this proved to be kind of heavy and not needed for flight. It only has the one camera mounted to it right now. But this can be used again in the future. It has enough battery life to last through multiple flights without needing to be recharged. Really, you could go a lot smaller with this. But that's what this is for. There's also cables. I'll talk about cables as well here in just a moment. Next up, we have antenna. As you can see, there is quite a collection of antenna here. These are all dipole antennas. These were included with the transmitters. We did decide to upgrade to a polarized, circular polarized antenna, which is what this is right here, the SpiroNet from Immersion RC. And that's what those look like. There's an extra set here. I believe there's one more. These can be used if you had a second camera connected for both that transmitter and the other monitor, which is right here. Is the second monitor. There's display 2 there. Currently, though, they're just being held and backup just in case they need to be replaced on the device or on the display. All right, right here, let's talk about this. This is a programmer board. It's a USB device that you'll plug in, and if you ever need to update the firmware, so each of these speed controllers has its own firmware on it. I believe it actually says right here, yeah, it's Simon K. That's the firmware installed on these. But if you ever need to upgrade it or change it to a different firmware, this is the tool that you would do that with. Connect it here through the two pin through the cable that comes out the side that would normally go to the speed controller. That goes right there, and that's what that device is for. All right, now there's also the label maker, which is right there. Pretty self-explanatory, used to make a lot of the labels. Now I'm going to talk about connectors and other bits and pieces like that. Right here we have bullet connectors. We bought a lot more than we needed because these, you can go through a lot of these. They're used for all of the power connections on the main board of the drone. Yeah, they're used in a lot of different places. The ESCs already come with them attached. They're pretty easy to solder on. Next up, we have the box here, which originally had the heat shrink tubing in it. This has got different screws in it. Now, the screws for the device there are different screws. There are these screws. They're both black, and they both have hex heads. These ones are slightly larger, and there are also longer variants of them. Now, these are screws that come with the motors. The longer variants are used for screwing the props onto the motors. And there's also a set of washers here. These washers have a small silver piece that goes inside of them. It acts like a bushing. Let's see if I can find one here. Here's one. So there's like the little bushing that goes inside of here. Let me just demonstrate how that would go in. So like you have this bushing has a slightly wider end at the top, and you would put that. It's kind of hard to do one-handed. Put that in there, just like that, and then this mounts this way on top of the motor, and then you put these screws down through it and the prop. The prop goes under this, and that's how you mount them this way. The shorter ones are for use either connecting the motor to the frames, to the arms, or to connect these. Now, these are, they thread on backwards. The point of these is that we have two different sets of props here. These are the ones that are mounted to it now that screw directly in. Those can loosen up over time. And then we have these, and these are a set of like bushings for those as well. These go onto the shaft that you see here. This unscrews, and the washer goes on top. And then those 4 screws you see there, those will screw into the top of the motor. So if we look here, so those 4 screws, that's how that lines up there. Also in here, let's see, there's the other part for the sled on the Mobius. There's some 3M adhesive pads. Here's one of the infrared LEDs. Some more of those other parts. Yeah, these silver screws are used for the body, the landing gear of the craft. And those screw into this plate right here. So there's that plate. There's also brackets for it. Here are the brackets, and those go onto the poles that you see there. If you ever wanted to um, mount a gimbal, I'll talk about a gimbal here in just a moment. So that's those parts. Here's another part of the landing gear right there. Up next is heat shrink tubing. Most of this turned out to be too small for use with our wiring. It wouldn't have been originally when we bought it because of the wire we were using. I'll show the wire here in just a moment. It's very important what wire you choose for a drone. Not all wire is equal when it comes to working with these. Last component type thing I want to show off are these LEDs. So there's a set of blue, white, green, red, and yellow LEDs in here of 2 different sizes. Um, Initially, we were going to do more work with these and connecting them to each arm. That's a possible upgrade in the future. Yeah, but we did not get these wired up in time. These would also likely be connected to a secondary battery, which is also an upgrade you could consider in the future. That can be used for the cameras, the LEDs, or other attachments like this. All right, now I'm going to move on to wire. Wire is very important when it comes to building drones. You have both your standard cut cables and then like what type of wire you use to wire up, like the wire between your speed controllers and the power distribution board. So initially we were using this wire, and this comes from Radio Shack. It's a relatively high gauge wire, and it's got a rubber shielding on it. And ultimately, this stuff is not what you want to use. Don't use this wire. Um, it's well known now by us because we figured it out the hard way that this stuff melts when it gets under load because of the high amperage of a multi-rotor circuit. So whatever you do, do not use wire of this type with the rubber shielding and the very high gauge. So don't use this. The type of wire you do want to use is silicone shielded wire. And this is what it looks like. It's a lot lighter than rubber, and if you can see here, it bends quite a lot more flexible as well. We used up most of this gauge wire. This is a smaller gauge. Let's see if I can see what size it is. This is 16. This is gauge 16 wire. We have black there, red, and this is what's used for the majority of the wiring, as you can tell, considering there's not much left of it here. What's used for the wire between the battery and the main board and anything that's directly connected to the battery is this right here. And this is, see here, this is 10 gauge wire. There's a lot of this left. It can be used to wire up batteries and stuff like that. Yeah, this is also silicone wire. A lot better to use than the rubber shielded and the higher gauge wire. So this is the type of wire you want to use. You can get it off of Amazon, and it's just silicone wire. And the 2 gauges, once again, are 16 and 10. Remember, always when you're dealing with the wire gauges, you should never go down in gauge. If you're going from like a 10 gauge down to another gauge, then you really shouldn't do that. Really, that's something that probably should be changed on the drone, making it more consistent. You can go up in gauge though. So if you're going from like a 16 gauge to a 10 gauge, that's okay. Now I'm going to talk about some of the other wires that are somewhat pre-cut or somewhat pre-made. These wires, these connections here are for AV. These are for connecting sources to the transmitter, like this one right here. You see there's that connector. There's also the power connector there as well. These do not have another end on them. The only one that has an end is currently on the drone and connects the OSD to the transmitter. But there's three of these right now. Two of them have been used on Raspberry Pis, but they can be used to connect to any kind of video source. Your wires here are the yellow there is your video. Let's see if we can get it to focus. Come on, focus. There we go. The yellow is your video. You got white and green for your left and right audio, and then you have ground and 5 volts. So that's your that's how that's wired up. Now we have these wires, okay? So these are the same wire as what connects the ESCs to the flight controller. It's got a brown wire, a red wire, and a yellow wire. The red wire actually does transmit voltage, and then the brown and the yellow are actually the important wires for control. These are included with the flight controller so that you can connect the transmitter to them. The way the transmitter is connected now actually only uses one of these wires. But if you needed to connect it a different way, for instance, for each input, throttle, yaw, pitch, roll, any of them, you'd have to use another wire. And that's what these are for. They can be used for other purposes as well. You see this one here that's a lot longer than the others. This is intended to be used with our gimbal. I'll talk about the gimbal here in a moment. Yeah, this one was carefully wired together by one of our team members. We're not using it currently, and we'd have to make another one in order to control that gimbal because it has 2 motors on it. All right, moving along here, we have some just straight up cut wires, pre-made wires. Here's a micro USB cable. You can use this to connect to the DJI NASA LED from the computer. This is an extension that we used for a little bit on the battery, so you could charge it without having to mess around inside of the drone to try and find the charging port. This is a European power connector that came with the charger because everything is shipped overseas. So there's that. If is of any use. Now these cables are kind of interesting. These are this is a mini jack connector here. This plugs into the display, and it goes out to standard composite input. So if you wanted to, you can connect any kind of source directly to the display. And there's 2 of these, of course, with 2 displays. Now there's some extra charging cables. These are charging cables with alligator clips on them. There's not really a good use for these right now, and they're kind of dangerous to use because you can really easily short out your equipment. There's 2 sets of those. And then here are a set of clips for you to actually plug it in the charger. I believe it can be connected to a car battery. That's what these are for. And you see there that's the same terminal as what comes that goes into the charger. Now I'm going to take a minute and talk about the damaged or destroyed flight hardware. Over the course of working on this project, there were times when during flying or testing and other parts where hardware just either didn't work or wasn't used correctly. And these are the components that that no longer work either fully or not at all. First off, during early testing, we did break a motor. This motor, the magnets inside of it are broken. If you turn it, it's really difficult to turn. Sometimes it makes bad noises. This is why there's a whole set of new motors included. But this is the broken motor. Also here this is a NASA light. This was our flight controller for like the first year and a half of us working on this drone. And ultimately, because of a couple reasons, we ended up replacing it. The flight controller and the GPS antenna and the LED, which are right there, they all work fine. However, what does not work fine is the PDU board here. And this is the case of what can happen when you short out a component on the drone. If you look here, this is the wire that normally would go to the flight controller. If you see there, it's actually fused to one of those linking wires that I showed earlier. So this is why you should never connect anything backwards. It was these connections right here. And when this device, when this component went bad, we ended up replacing them. We also ended up replacing the ESCs as well for higher amperage and better model. We don't have any more of the old ESCs though. Here's the gimbal. The gimbal can be restored to a working order. It's not the best gimbal. Uh, Working with the device itself, working with the board here and flashing the ROM on it is difficult and doesn't always work. Here's the actual tool that you use to flash it, which is this clear USB device, and it goes out to this connection right here. It's got the terminals where you would connect it to the motors, where you connect the motors to the board. It's supposed to control its orientation. Um, you can see here it's mostly disassembled. If you look on the bottom here, this is the board that actually sends the data back about the position of this piece. And as you see here, there's no lead coming off of it. The lead broke off during a flight test. Here's the lead. Someone with very steady hands might be able to solder this back on, but right now this is inoperative. Um, and currently, there's not really a good way to mount this as well. You can mount it using this, but it'll make the machine off center. All right, so last off, I'm just going to talk about some of the other boxes and things. There's a whole box full of paperwork. Here's the boxes for the flight controller. That's actually a mounting for a GPS antenna. This box was actually 3D printed by one of our team members. Ultimately, ended up being too bulky to carry with the drone, but it can be used for other purposes. Lastly, I want to talk about tools. I understand this video has gone on for a bit, but I just want to talk about the different tools needed to service the device. First and foremost, of course, and I've mentioned it a couple times already, is a soldering iron. You have to use a soldering iron to connect literally just about anything on the drone. Most connections don't come with connectors already on them. A great tool for this is to use these helping hands. This is actually kind of invaluable. We didn't have one for a lot of the time working on this, but after using one, I can say that it's a tool that would have made working on it a lot easier. To insulate everything, we have electrical tape. You can hold things in place with masking tape or whatever kind of other tape. Here's a utility knife, stripping wires and such. A sharp pair of scissors and a pair of needle nose pliers. There's also a small hacksaw which can be used for more aggressive work on the drone. And last off, I want to talk about bits for the screws I mentioned earlier. Now, the screw heads are not the same. The one on the left here is the bit for the body screws, for the screws on the plate, and the one on the right is the one I've used in the past for working on the working on the motor. You'll have to find a driver that will fit it. Um, this is a hex head driver, but that's the type of tools that you'll need to work on the drone. Um, and that's about it as far as other components. It was a long road to get here and get all these parts tested and everything. So that is it. Thank you very much for watching.